Hello, class. This is Mr. Hart, and in this podcast, I want to start the chapter on minerals. And you may have heard of the word mineral before, but you may have not known what a mineral really is. So, what is a mineral? You may have heard of things in like your cereal or your food that the minerals for your body or things like that. But what is a mineral? Okay. Well, a mineral has to meet certain conditions, and I think of something like salt. Okay, what makes salt unique compared to other substances? Well, these are the things that make it unique. Okay, these are the things that make salt a mineral or anything a mineral. Okay, first of all, it's a solid. Okay, so any mineral must be solid. You're not going to have liquid minerals or a gas mineral. Okay, it doesn't make much sense. Okay, so it's got to be solid, and it must be crystalline. Okay, meaning that it has a repeating arrangement of atoms. Okay, we'll look at that more in a second. Okay, it must be naturally occurring. Okay, so nothing that we make, you can't artificially make a mineral. Okay, it's going to be a naturally occurring substance from the earth. It's got to be inorganic, meaning it can't have any life forms in it. It can't have any organisms. And then the last thing is must have a specific chemical composition. Okay, so salt or table salt's always going to be sodium chloride. Okay, that's not going to change it. For any mineral, its chemical composition is always the same. Okay, so anything that has these properties is going to be a mineral. Okay, and so let's look at this one right here, the crystalline structure. This one's really important. So you may remember from a while back, we did talk about crystalline solids. Okay, but let's look at it again where we have some type of compound, for example, maybe sodium and chloride, something like that. And when we put this compound together in large groups, it forms a pattern. Okay, so you'll notice you can see these lines of the purples and greens going through. Okay, and so this pattern is consistent. So it's a crystal, is what we call it, or crystalline solid. So any crystalline solid is going to have this repeating arrangement. And any mineral, when we break it down, is also going to have this repeating arrangement. Okay, so this is really important. Any type of crystal that you see is probably some type of mineral. Okay, so here's just a couple of examples of minerals. Okay, this is just some pictures from the textbook. We have things like olivine, feldspar, halite, pyroxene, okay, gypsum. Okay, you can see the kind of crystal nature of them. They kind of look like glass a little bit, but I always have the kind of that crystal structure. Okay, here are just some other ones: biotite, quartz, calcite, hematite, things like that. Okay, and so again, not the most commonly used day to day type substances. Okay, but minerals are still very important, and there are a lot of them, a lot more than you might think. A lot of naturally occurring minerals. Okay, but let's look at what makes a mineral unique. Okay, compared to other minerals. Let's look at some of the physical properties of minerals. Okay, so unlike when we were talking about chemicals, you know how I said if something looks like water, tastes like water, smells like water, it's not necessarily water. Well, this is not the case for minerals. In most cases, we can look at the physical properties and we can identify the mineral by those physical properties. Okay, so this is something that's pretty unique to minerals, that they're very identifiable from physical properties. Okay, we don't have to use some type of chemical test on them to figure out what they are. Okay, so one of the physical properties we use is color. Okay, just looking at the color of the mineral. Okay, we'll get through all of these in a second, but let's just look at the different ones. So there's color. There's one called streak, which is the color of the mineral's powder. Okay, which is often different from the color of the whole mineral. We have luster, which is basically how shiny it is, or if it's not shiny. Its density, which is its mass per volume. Probably familiar with that. There's a couple of other ones. There's cleavage, which is the mineral's tendency to break along certain lines. Okay. There's fracture, which is the pattern in which a mineral breaks. Okay. Does it break in chunks? Does it break in columns? Does it break in sheets? Things like that. And then the last one, which is probably one of the most important ones, is the hardness. Okay. What a mineral can scratch and what minerals can scratch it. Okay. And so let's just go through each one of these one by one and kind of look at some of the different characteristics. Okay, so the first one is color. Okay, so if we're identifying a mineral, the first thing we want to look at is color. Okay, so is it kind of purplish color? Is it green? Is it clear? Is it blue? Whatever color it may be, that's what we're looking at. Pretty easy to identify. Okay, but this is not the best way to identify a mineral because colors can change between the same minerals. So, for example, this is a quartz crystal in both pictures. Okay, one's purple, one's clear. Okay, totally different colors, but still the same type of mineral. So, color is not the best identifying feature. One that is a lot better is the streak. Okay, so the streak of a mineral is the color of its powder, which may not be the same color of the mineral itself. So look over here. We have a picture of a mineral, okay, which I think it's hematite, okay, and we have what's called a streak plate. So when we scratch this mineral along the streak plate, it actually makes this brown color, okay, whereas it's hematite itself is more of a black, red color, whereas this streak plate shows a brown color. So this is the streak of the mineral, and so anytime you take any type of hematite mineral, it's always going to have that brown streak color, okay. So the streak of the mineral is consistent, whereas the color may not be. So this is really important. This is really a key feature. One good example of this is fool's gold. Okay, pyrite. If you've ever used fool's gold or know what fool's gold is, you know that one of the ways you can tell that it's fake is by using a streak plate. Because gold, when you scratch it on a plate, it's not going to have any type of streak color. If anything, it's going to be a gold streak. Whereas if you take pyrite, fool's gold, and you scratch it, it actually has a black streak. So that's one of the ways they identify fool's gold is with the streak plate. So that's an example of a mineral test, right? Using the streak. Okay, so very important. Okay, let's move on to some of the other ones. Luster is another important identification for minerals. Okay, and luster is, again, we call it shininess, but there's lots of different lusters. Okay, there's a metallic luster, there's a submetallic luster, adamantine, which is more like a sci-fi looking crystal luster, resinous, which looks like, sap or amber, vitreous is kind of glassy, pearly, greasy, dull, earthy, silky. Okay, all these different kinds of ways that the light can reflect off the mineral. Okay, which gives it kind of this unique feature to it. Okay, so we call this luster. And so some of the ones I want you to know, I put in this table for you to kind of write down. Okay, so the luster type or how we classify it's over here, and then what it looks like. So metallic makes it look like iron or steel. It reflects very well and has kind of that, again, just metal look to it. Some metallic makes it look more like an ore. Okay, not so much like a metal itself, but more like an ore for a metal or something like that. Adamantine is just a very sparkly luster to it. Earthy is very dull, clay-like. Pearly, simple enough, it makes it look like a pearl, reflects light like a pearl. Resinous makes it look like a resin or some type of amber. Silky is very soft looking with like fibers. Okay, you can kind of see lines going through the mineral itself. And the last one is vitreous, which makes it look glassy. Okay. So when you're identifying minerals, one thing you want to do is identify the luster. Okay, this is also a very consistent way to identify minerals across the same type. Okay, for example, quartz, always has this very vitreous look to it, or maybe adamantine luster about it. Okay, so every quartz crystal, no matter what color it is, usually has this very nice adamantine luster. Okay. All right, and the last one is hardness. Or sorry, not the last one, but the last one that we use to identify minerals usually is hardness, and what we use is what's called the Mohs scale. Okay, so the Mohs scale identifies minerals based on how hard they are and kind of puts them in their group. So it's named after the man who discovered it, Mohs. And what he did is he basically said, I'm going to find the strongest mineral and I'm going to find the weakest mineral. And he kind of went through, and diamond's pretty much the hardest mineral you can find, and talc's probably one of the weakest ones you can find. He said, I'm going to make diamond 10 and talc 1. Okay, because I know that everything can pretty much scratch talc. And I know that diamond can pretty much scratch everything. So this must be the strongest, this must be the weakest. And so he went through and he said, diamond can scratch this, and but this can't scratch this, and this can scratch this, but this can't scratch this. And he just started comparing all the different minerals. What can gypsum scratch and what can scratch it? What can apatite scratch and what can scratch it? And he went through hundreds and hundreds of minerals, and he figured out that every mineral can have a hardness between 1 and 10. Okay, so he kind of defined this scale, and every mineral is given a number between 1 and 10 based on what it can scratch and what can scratch it. Okay, so it's just comparing the different hardnesses. So I know topaz is an 8 and apatite is a 5, so I know that topaz can scratch apatite. Okay, or calcite is a 3 and corundum is a 9, so corundum must be able to scratch calcite. Okay, so he just assigned all these different minerals. And again, it's not just the 10 that are shown here, but there are hundreds of minerals, and every one of them has a given hardness. Okay, so this is useful because all we have to do is we have to know, one type of mineral's hardness to be able to compare it to another. So if I don't know the hardness of quartz, well, I could take topaz, I could take feldspar and say, hey, topaz scratches quartz, but feldspar doesn't, so quartz must be a 7. Okay, so that's what he did, and this is what we do. Whenever we classify a mineral, we just take known hardnesses and we use it to find the hardness of the mineral we're looking for. Okay, really easy to do, really practical. Okay, and it's also very practical because we have some common objects we can use. Like our fingernails, we know they're a hardness of about 2. Pennies are a hardness of about 3. Glass is about a 5, and a steel nail is about a 6. Okay, so we don't even have to have the minerals. We can just use these other objects that we have to find hardnesses. Okay, so a really slick way of finding the hardness of an object, okay, or a mineral. This is kind of another look at it, but again, this shows 1 at the bottom and 10 at the top, and the hardness increases as you go up the scale. Okay, but really nice, really slick way of comparing hardnesses. So let's try one. Or try a question. So if a mineral is scratched by glass but not scratched by calcite, its hardness is closest to 2, 4, 7, or 9. Okay, so how we'd figure this out is we say, well, glass has a hardness of 5. Okay, if we go back to our table and we look, we say glass had a hardness of about 5. Okay, so we know glass is a 5 and calcite is a 3. Also from the table. Okay, so a mineral is scratched by glass, okay, so it's got to be weaker than glass, but it was not scratched by calcite, so it's got to be stronger than 3. Okay, well, if it's stronger than 3 and weaker than 5, we know that it's got to be 4. Okay, so the answer is B in that case. Okay, so really simple, really easy way of figuring out how hard minerals are. Okay, let me have you try a couple on your own if you're doing this for participation. Okay, so try this one. If a mineral is scratched by corundum but not scratched by quartz, its hardness is closest to A3, B5, C8, or D10. Okay, so answer that one. And then here's another one for you. A mineral is scratched by a penny but not scratched by a fingernail. This mineral could be A, calcite, B, gypsum, C, topaz, D, diamond. All right, so let's move on to the last one I want to talk about, which is cleavage and fracture. Okay, so again, this can be used for identifications. It's not as common for identifying minerals, but it's a very important feature of minerals. Okay, and it's basically how the mineral breaks along certain planes. Okay, and how it breaks. So you'll notice this mineral is not a nice rectangle. It's got some chunks spinning out of it. But you'll notice that whenever it was broken up, it always was a nice flat line. Okay, kind of this column look. Okay, so things can break along these lines, okay, along the mineral, okay, which is cleavage. And this fact that it's breaking along columns is its fracture. Okay, and there's lots of different patterns. Some break along sheets, okay, kind of break up into sheets. Some break up into little chunks. Okay, some kind of break like glass, where you get these different shards of glass. Okay, and some break along really nice planes, kind of like when they cut diamonds and things like that. Okay, and so every mineral is going to break in certain patterns. So if I take this mineral, for example, it's not going to naturally break along a line up here or something like that, right here. So if I try and break this mineral along this plane right there, that's not going to happen naturally. Okay, it's not. It's going to take a lot of work and effort. And even if I try to break along that line, it may not be perfect even after that. Okay, so it's not naturally going to want to break along that plane. Okay, and so that's cleavage and fracture. It wants to break along certain lines and not along others, or it wants to break up in groups like columns, or it wants to break up in sheets or things like that. Okay, it has natural breaking points. Okay, and then the last thing we want to talk about is there's some other identifying characteristics again that aren't as common, but some minerals do have them. Okay, some minerals are fluorescent, which means they glow under ultraviolet light. Some minerals are magnetic, okay, which means they attract to a magnet. Some minerals are radioactive, and sometimes we need to use another test, which is reactivity, which is we put in an acid or something like that to make it chemically react. Okay, so if we're really having trouble to identify certain minerals, we can use some of these other tests to figure out what the mineral is. Okay, so that is all the identifying factors. And the last thing we did is we did a lab that we went through and actually tried to identify a couple of minerals. Okay, but hopefully this all makes sense. I hope it's pretty intuitive and it's kind of an interesting way to look at substances and minerals and be able to identify them by these certain features. But hopefully that made sense. Let me know if you have any questions. And